Okay, this whole integration by parts thing can be super challenging to work with, and getting it all organized. Ugh. And what happens if you have to do it lots and lots and lots of times? Well, lucky for us, there's a form of integration by parts. It's called tabular integration, and it works pretty much the same way. You're going to take derivative of one side, you're going to integrate the other, and you're still going to follow the integration by parts rule. Basically, here's the setup. If we've got x squared e to the x, what we're going to do is we're going to make a table, and we're going to let f of x equal x squared, okay? And I'll show you why we picked this in a minute. Then we're going to let g of x equal e to the x, okay? And what we're going to look at right here in purple, in this plum color, is we're going to derive. So we're going to look at the derivative. And in blue, we're going to integrate. Okay? So in purple, if I take the derivative of this, I have x squared, then I have 2x, and then I have 2, and then I have 0. Okay? That's just a straight up derivative here in this purpley color. Then if I integrate e to the x, I have e to the x, and then e to the x, and then e to the x, because the e to the x, it integrates to e to the x. And okay, so we love this. All right, now here's the cool thing. I'm going to draw arrows starting with my x squared here that look like this. And they are connection points, okay? And the first arrow, we're going to do a plus. The second arrow is going to be minus. The third arrow is going to be plus. Now, what's going on here? Well, this is where integration by parts kicks in. If I take x squared times positive 1 times e to the x, that'll get me my first term using tabular integration. So if I integrate x squared e to the x, this is what I'm going to get. I'm going to get x squared e to the x, okay, positive, and then 2x times negative 1 times e to the x, so minus 2x e to the x, and then 2 times 1, positive 1, times e to the x, plus 2e to the x, plus c. So this is a form of integration by parts, and sometimes it's easier to use and sometimes it is not, but here we go. This is integration by parts, tabular integration, and so that this integral right here, if I evaluate that, it equals x squared e to the x minus 2x e to the x plus 2 e to the x plus c. So this is really kind of a cool way to do it. Well, what about this guy over here? The same thing. Think about what we can take derivative of that will simplify. Well, that's going to be x cubed. So I would let f of x equal x cubed. The integration part, which will not hopefully get really difficult, for the most part will remain manageable, will be sine x. Okay, so if you want to think about it, f of x is that u. So what do you want to look for first? Natural log, inverse trig function, then polynomial, and work your way through that list. And so now when I take my derivatives, I have 3x squared, then 6x, then 6. And we'll probably be okay here, but we'll add 0 just in case. On the other side, sine x, when I integrate sine x, I get negative cosine x. And then I get negative sine x. And then I get cosine x. And then I get sine x. Okay? I just integrate backwards the whole way through. And then I connect, starting with my x cubed, to one level underneath, right here. All right? And then I'm going to start with a plus sign, and then minus. Plus, and then minus. So here's my tabular integration. It's all set up and ready for me to use. And what's it going to be when I'm done? It's going to be this integral right here. This integral is going to equal x negative, because x cubed times positive 1 times negative cosine x, negative x cubed cosine x And then 3x squared times negative 1 times negative sine x. Negative times negative is positive, so plus 3x squared sine x. And then 6x times cosine x plus 6x cosine x. And then 6 times negative 1 times sine x minus 6 sine x plus c. And that's tabular integration. It's really handy, especially with some of the more longer versions of integration by parts, where you would have to do integration by parts several times. And it's just really an easier way to do all of that, okay? You still have to follow all your rules. Purple is still the U. Blue is still dV. We still want to follow those rules to set those up. But this takes some of the difficulty out of actually working through integration by parts integrals.